Some might ask, what is nuclear energy? Where does it come from? What does it do for us? How is it useful? Nuclear energy usually means the part of the energy of an atomic nucleus, which can be released by fusion or fission of radioactive decay. Nuclear power is the use of sustained fission to generate heat and electricity. Nuclear power plants, where this happens, provide about 6% of the world's energy and 13 to 14% of the world's electricity. Electricity, which plays such an important role in our lives, is generated in power plants. This interaction depicts a pressurized water reactor, or a PWR, nuclear power plant. The function of any power plant is to convert some material or source of energy into electricity. A nuclear power plant uses steam to generate electricity, the same as fossil fuel power plants. The major difference between a fossil fuel power plant and a nuclear power plant is the method used to heat the water and to produce the steam. In a nuclear power plant, uranium takes the place of coal, oil, or gas to be used to heat the water and produce the steam. A nuclear reaction occurs when uranium atoms split into smaller particles in a chain reaction that produces a large amount of heat. This heat producing fission process is controlled in a reactor. The core reactor contains the uranium fuel. Now this release of energy heats water that is being circulated around the reactor, and then the steam is sent into a turbine, and then when the turbine's turning, it is sent to a generator, and then in turn producing the energy. But what is the problem here? What is the major thing that people are worried about? Nuclear power plants produce a large amount of radioactivity. Some people don't understand how much this can have an effect on your lives. Nuclear power produces radioactive material. Let's give one example of a disaster. Something bad that can happen. The Chernobyl disaster, located in Ukraine. This was a catastrophic nuclear accident that occurred on April 26, 1986 at the Chernobyl nuclear power plant in Ukraine. Now this power plant was under the authority of the direct central authority of Moscow, when an explosion and fire released large quantities of radioactive contamination into the atmosphere, which this contamination spread over much of the Western USSR and Europe. It is widely considered to have been the worst nuclear power plant accident in history, and one of the only two to ever reach level 7 on the International Nuclear Event Scale, other than the Fukushima Daiichi nuclear disaster, which happened last year in Japan. The battle to contain the contamination and avert a greater catastrophe ultimately involved over 500,000 workers and costed an estimated 18 billion rubles, crippling the Soviet economy. Now, is it really worth it to risk all that and risk all that money that can be put in other places? Now, what is the future of nuclear energy? If global carbon emissions were cut by 15% by 2050, by the increased use of a nuclear power, 1,070 power plants would need to be built at a cost of $5 trillion. Although not much waste is produced, it is very, very dangerous and it must be sealed up. And this waste has to be buried for thousands of years to allow the radioactivity to die away. For all the time it must be kept safe from earthquakes, flooding, terrorists, and everything else. This can be very difficult. We don't have much control over everything that happens on our planet regarding the nature of things. Nuclear power is reliable, but a lot of money has to be spent on safety. If it does go wrong, a nuclear accident could be a major disaster. People are increasingly concerned about this, and that is what's worrying a lot of people. In the 1990s, nuclear power was the fastest growing source of power in much of the world. Now, by 2005, it was the second slowest. Nuclear energy from uranium is not renewable, which people might think, oh, it's renewable source of energy, it's going to be great. No, nuclear energy from uranium is not renewable. Once we've dug up all this Earth's uranium and used it, there's no going back. Nuclear power stations work in pretty much the same way as a fossil fuel burning station, except in a chain reaction. Nuclear power costs about the same as coal, so it's not that expensive to make. That's not the expensive part. It's the protection and the cost of the power plant building that costs so much. Nuclear power does not produce smoke or carbon dioxide, so it does not contribute to the greenhouse effect. But it does produce a huge amount of energy for small amounts of fuel. And it does produce small amounts of waste. It is reliable, but this waste is very, very dangerous. Throw in the fact that the cost of storing this nuclear waste could be up to $24 billion. And figure that will likely rise while there's more waste being produced and more people using nuclear energy. It's just going to get more and more expensive. And the environmental groups are dead set against a central facility. And it shapes up to be a challenge of colossal proportions. The process of finding a site to bury this high-level spent fuel has dragged on for decades. People don't know where to put this radioactive waste. You can't just put it anywhere. It has to be in a place that is secluded from everyone, and generally they like to put in ice caves. So when these ice caves tend to collapse, it will protect the radioactive waste and it won't be exposed. Here you see the Fukushima Daiichi nuclear disaster. On March 2011, in Japan, something went wrong. There was an earthquake. Something that people cannot control. It's nature. These things happen. But no, the government says everything's going to be okay with these nuclear plants and nothing's going to go wrong. Well, you can't control everything, Mr. Government. And Mr. President, you can't control everything. See, this plant comprises 6 separate boiling water reactors, originally designed by General Electric, GE, and maintained by the Tokyo Electric Power Company. At the time of the quake, one of the reactors had been defueled, while 2 of the other reactors were in cold shutdown for planned maintenance. The remaining reactors shut down automatically after the earthquake, and emergency generators came online to control electronics and cooling systems. The tsunami, therefore, however, broke the reactor's connection to the power grid and also resulted in flooding of the rooms containing the emergency generators. Consequently, those generators ceased working and the pumps that circulate cooling water in the reactors ceased to work, causing the reactors to begin to overheat. The flooding and the earthquake hindered external assistance, therefore no one else was able to help. In the hours and the days that followed, reactors 1, 2, and 3 experienced full meltdown. As workers struggled to cool and shut down the reactors, several hydrogen explosions occurred. The government ordered that seawater be used to attempt to cool the reactors. This had the effect of ruining the reactors entirely. But they were willing to take the risk, considering that there were huge fires and explosions on their hands. Money can be a very big issue for people, and they don't want to just give their money for nothing. So therefore, look at the next picture. In the next 20 years, 1/3 of America's nuclear power plants will reach the end of their lives. The end of their lives being able to produce. Now, that means they're going to need to be replaced. The cost to replace one is $41 billion. Now, the amount of jobs created by replacing that nuclear power plant, 2,400. You want to save money and create jobs? Get efficient. For half the cost of replacing one nuclear power plant, we can rebuild 1.6 million homes for energy efficiency and create around 220,000 new jobs. That's 90 times more jobs than you get from a power plant replacement. Now make the right choice.